Welcome to Manifested Publishers.
Welcome learners, my name is Stephen Kariungi. Today we continue with our topic of discussion on the structure of the atom and the periodic table. And today we are discussing ion formation. Before we get into more details about ion formation, we know that an ion is a charged particle. And that charged particle is obtained from an atom. An ion is a charged particle that is obtained from an atom. So in other words, we are saying that an ion can either have a positive charge or a negative charge. Is a charged particle obtained from an atom either by gaining of electrons or losing electrons. So for example, if you take an atom like sodium, a sodium atom that is Na281, that is the electron arrangement, we can say that that atom is unstable. It's unstable because not all the energy levels are fully occupied by electrons. So the third energy level is not fully occupied by electrons. So we can say that this is unstable. This is an unstable atom. In order to become stable, this atom can either lose this one electron or it can gain 7 electrons so that it attains a stable electron arrangement of either 2,8 or 2,8,8. So to attain that stability, it needs to either lose the 1 electron or to gain 7 electrons. So you can say that a sodium atom 281 is unstable because not all energy levels are fully filled with electrons. So to become stable, the sodium atom needs to either lose this 1 electron or to gain 7 electrons, so that either this energy level is not there or we have 8. Needs to lose 1 electron or gain 7 electrons. So in the case of sodium, we can say that it is easier for sodium to lose 1. For sodium to lose 1 electron to attain a stable arrangement of 2,8. So if it loses 1, now it becomes stable. It has all the energy levels filled up with electrons. So it is easier to lose 1 electron than to gain 7 electrons and attain 288 arrangement. So in this case, we are going to show how sodium loses this one electron. And what happens is that when this sodium atom loses one electron, it will form a sodium ion. And that's why we're saying that an ion is a charged particle obtained from an atom either by gaining or losing electrons. So when this one electron is lost, now the number of protons and electrons will no longer be equal. Initially, in an atom, the protons and the electrons are initially equal. But when we lose one electron, now the protons will be more by one. So we have a sodium atom. In its nucleus, it has 11 protons, 12 neutrons. The energy levels has 2, 8, then 1. So this is a sodium atom. Na, the arrangement 281. So in that case, we are saying that it is easier to lose this one electron so that the other energy levels that remain, they are stable or they are fully filled with electrons. So in this case, it loses one electron. So once it loses the electrons, or once it loses the one electron, the protons and the neutrons are not affected. They remain as they are in the nucleus. What changes are the number of electrons. Also, the first energy level is not affected. So they remain 2 as before. The second energy level is also not affected. They are 8 as before. So that is 2,8. So it has already lost the outermost energy level. So now we have it as sodium 2,8. Now in this case, the number of electrons are 10 because it's 2 plus 8, but the number of protons are 11. So that means that the protons are more than the electrons by 1. And since the protons are positively charged, then we shall form a positively charged ion. So that extra proton is what makes that particular ion to be positively charged. So now it becomes a sodium ion. A sodium ion, and then with a positive charge, to show that the number of protons or the number of positive charges are more than the number of electrons, the negative charges, by 1. So that is how sodium forms its ions. So we're going to have another example. So this is example 1. We go to example 2. And this one we shall use a chlorine atom. Whose arrangement is 287. Is also unstable. It's also unstable. And to become stable, it needs to gain one electron. It is easier to gain one electron here than to lose all the 7. By gaining so to become stable, it requires to gain 1 electron. And as a result, the number of electrons become more by 1, hence acquire a negative charge. So we'll have a chlorine atom, 17 protons and 18 neutrons. So here we have a chlorine atom, Cl287. So we are saying that this one will gain 1 electron here because this is the energy level that is unstable. It needs 1 more electron. It is not fully occupied, so it gains 1 electron. And once it gains 1 electron, it looks like this. The nucleus remains the same, 17p18n. First energy level remains the same. Second energy level also remains the same. But the third energy level gains an extra electron. So now this one will be Cl288. And because there is 1 extra electron that has been gained and it is negatively charged, so the particle becomes negatively charged. And we refer to it as a chloride ion. And then at the diagram, we show the negative charge there. So that shows that chlorine gains 1 electron during ion formation to become stable, while sodium loses 1 electron to become stable. When it loses 1 electron, it becomes positive because now the protons are more by 1. When it gains 1 electron, now the electrons are more by 1, so it acquires a negative charge. So generally, what happens is that metals lose electrons to form positively charged ions, whereas nonmetals gain electrons to form negatively charged ions. So that's a point to note, that generally metals lose. Metals lose electrons to form positively charged ions. And those positively charged ions are called cations. These ions are called cations. They are positively charged. On the other hand, nonmetals gain electrons. To form negatively charged ions called anions. So we have cations and we have anions. The assignment: using a dot and cross diagram, show ion formation in A, magnesium 2412, that's the mass number, atomic number. Fluorine 199, mass number, atomic number. Aluminium 2713, mass number, atomic number. So we'll stop there until next time. Goodbye.